Dear students, welcome to SRK online classes. Today we are discussing about important name reaction related to the carbonyl compounds. The last videos we have discussed about aldol condensation, which is one of the important and probable question. The similar manner, Cannizzaro reaction is also an important question from carbonyl compounds. Difference between these two is, in case of aldol condensation, carbonyl compounds may be aldehydes or ketones, which contains alpha hydrogen atom in presence of alkali undergoes condensation to give aldol is called as aldol condensation. But whereas in case of Cannizzaro reaction, exactly reverse. Carbonyl compounds which are not having alpha hydrogen atom in presence of alkali undergoes disproportionation to give alcohol, and salt of carboxylic acid is called as Cannizzaro reaction. Two important points to be remembered. Number one, what is the condition for Cannizzaro reaction? One, without alpha hydrogen atom. If it contain alpha hydrogen atom, it undergoes aldol condensation. Without alpha hydrogen, it undergoes what? Cannizzaro reaction. That is the first condition. Second one, just like aldol condensation, here also we are taking 2 moles. But in the previous case, 2 moles of compound combines to give 1 mole of product. Condensation is taking place. But whereas here, 2 moles of compound produces 2 moles of product. One will be converted to alcohol, another one will be converted to salt of carboxylic acid. We know that simultaneous oxidation reduction of different elements or compounds is called as redox reaction. Here, same molecule, if it undergoes oxidation reduction, that is said to be disproportionation. Similar type of molecule or one molecule undergoes oxidation reduction is said to be disproportionation. Cannizzaro reaction is an example of a disproportionation reaction. In condensation, you are getting only 1 mole of product or 2 moles of product produces 1 mole. That is the difference between aldol condensation and Cannizzaro reaction. Let us work out the simple one. One more important point to be remembered. Aldol condensation follows second order kinetics. Cannizzaro reaction follows third order kinetics. That is another difference between aldol condensation and Cannizzaro reaction. I am taking the simple molecule to explain Cannizzaro reaction. First I am writing formaldehyde. This is the structural formula of formaldehyde. In presence of base, sodium hydroxide or potassium hydroxide, concentrated base, that produces 1 mole of alcohol plus 1 mole of salt of carboxylic acid. If you take sodium hydroxide, sodium salt is formed. If you take potassium, potassium salt of carboxylic acid is formed. Now we are starting with 2 moles of carbonyl compounds. Look at here, this is the function group. Next to the function group is called as alpha carbon. There is no carbon atom here. That is, there is no alpha carbon. Therefore, no question of alpha hydrogen. So, this compound is not having what? Alpha hydrogen. So, if alpha hydrogen is not present, it undergoes what? Cannizzaro reaction. 2 moles of formaldehyde we have taken. 1 mole will be converted to alcohol. Another mole is converted into salt of carboxylic acid. Aldehyde to alcohol is said to be what? Reduction. Aldehyde to carboxylic acid is said to be what? Oxidation. Same molecule undergoes oxidation reduction, therefore it is said to be disproportionation reaction. And important thing is formaldehyde on Cannizzaro reaction or on treating with concentrated alkali produces methyl alcohol and sodium phosphate is known as Cannizzaro reaction. Let us see the mechanism part of this one. Mechanism. First molecule I am taking formaldehyde in presence of a base. Now this pair of electrons are shifted here. Therefore, OH minus ion approaches here. that produces H, O minus and H and OH. This is the first molecule. Now, in the second step, in the slow step or rate determining step, RDS. Second molecule I am taking. This is second molecule. Polarization is taking place. Here, this negative charge is polarized and shifting will be taking place. Hydride ion shift. Is taking place in what? Rate determining step or the slow step. That is very, very important. Now, this first molecule will be converted into what? This molecule will be converted into H, H, O minus and H. And this molecule will be converted to what? H, C double bond O, OH. This carboxylic acid is stabilized through the resonance. Therefore, it undergoes rearrangement that produces methyl alcohol plus formate. This formate in presence of sodium ion that will be converted into methyl alcohol plus sodium formate. This is the mechanism of Cannizzaro reaction. First molecule OH minus ion approaches, forms oxyanion, hydride ion shift in the slow step or the rate determining step, forms oxyanion, methoxide ion plus formic acid. So this is relatively more stable. Therefore, exchange of proton is taking place. Methyl alcohol formate. This formate is a resonance. A resonance is possible. It is stable in presence of a salt that produces sodium formate and methyl alcohol. That is about the mechanism of Cannizzaro reaction. What is Cannizzaro reaction and how the products are formed and given the mechanism. Let us take one or two different examples to explain Cannizzaro reaction. I am taking the second example for Cannizzaro reaction. Benzaldehyde in presence of potassium hydroxide gives A plus B. What are A and B? Every time we cannot write the mechanism part of that one. Easiest way to write the final products from the starting compound is, see here two molecules are there. First molecule should be represented as it is, but aldehyde is converted to alcohol. Whatever the group which is attached with aldehyde will be the spectator. That will be represented as it is. Irrespective of the nature of the group, that group will be as it is. Only CHO will be converted to what? CH2OH, alcohol. The second molecule, whatever the group is attached with the CHO will be as it is. Then CHO is converted to what? COOH. This is sodium benzoate. This is benzyl alcohol. So therefore, benzaldehyde on Cannizzaro reaction produces what? Benzyl alcohol and sodium benzoate. How to write the product? First molecule should be represented as it is. Whatever the group which attached with aldehyde remains as it is. That will be here. In the first molecule, CHO is converted to what? CH2OH. In the second molecule, CHO is converted to what? COOH. Let us try for another one. CH3, 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 C double bond OH. Two molecules in presence of sodium hydroxide gives. Here you get potassium because potassium hydroxide we have taken. Now, what are the products formed? Just like the previous one, whatever the group which attached to the CHO remains as it is. Therefore, that group I am writing as it is here. And first molecule, CHO, is converted into what? CH2OH. The second molecule, whatever the group it's attached, remains same. Right as it is. And CHO is converted into what? COOH. That's the way to write the final products in the Kennesaro's reaction. Let us work out another two examples here. CHO and CHO in presence of sodium hydroxide gives. Same way of writing. CHO and CHO, sodium hydroxide, gives A. A on heating produces B. What are A and B? If you write the first one, in the previous case, what two molecules are there? CH2OH, CH2OH. Second one, COONA and COONA. If you write in this manner, it is absolutely wrong because both are not having alpha hydrogen atom. Part of molecule will be converted to alcohol. Therefore, correct answer will be one part will be reduced CH2OH. Another part will be oxidized to give corresponding compound. Therefore, this is the correct one and this is wrong. Two molecules are not produced. Single molecule produces another molecule where half of the part will be converted to alcohol, remaining half is converted to salt of carboxylic acid. The same manner I have given, but this aromatic compound. It will be same. First half is converted into CH2OH. Here I write the followed by hydrolysis. This is CH2OH and this will be COOH. Whenever it is heated, elimination of water is taking place, that produces B. Another cyclic compound. This will be as it is. This is CH2 and this is oxygen. Here C double bond O is attached with this one. That is the cyclic compound. And I write another one or two examples. Just find out the final products. Here I am writing CCl3 C double bond OH in presence of alkali. Write the product. In the same manner, sodium hydroxide. Write the product for these two. This question, previous one is given in one of the competitive examination. Here also there is no alpha hydrogen atom. What will write the Kennesaro's products? But here Kennesaro's products is not possible. They undergoes hydrolysis process that produces chloroform plus sodium formate. This is the correct answer, but not Kennesaro's reaction. This is exceptional case. Though it is not having alpha hydrogen atom, it does not undergo Kennesaro's reaction. Rather than it undergoes hydrolysis in presence of alkali that produces chloroform and sodium formate. The same manner, if you look at this one, here also there is no alpha hydrogen atom. Iso tertiary butyl group is present, and here no Kennesaro's reaction because of steric hindrance. Due to steric hindrance, it does not undergo Kennesaro's reaction. Similarly, I can give another exceptional case. If you look at this one, CH, CH3 and CH3, C double bond O H in presence of a base. What are the products from here? This is the function group. Alpha carbon is having hydrogen. If alpha hydrogen is present, it should undergo aldol condensation. Just like the previous case, here also due to the steric hindrance, it does not undergo aldol condensation. It produces what? Cannagerose products. First part will be as it is, and aldehyde will be converted to what? Alcohol. Second part, the group attached to this one will be as it is, and that will be converted to sodium salt of carboxylic acid. So this is an exceptional case. Though it is having alpha hydrogen atom, because of the steric hindrance, it undergoes Cannagerose reaction. Though alpha hydrogen is not present, but Cannagerose reaction is not possible because of steric hindrance. Here there is no alpha hydrogen. All three have given exceptional cases where Cannagerose products are not formed. Hydrolyzed products are formed like chloroform and sodium salt of carboxylic acid. So that's about brief introduction part of Cannagerose reaction and few examples. In the next video, we'll discuss about crossed Cannagerose reaction plus applications of Cannagerose reaction. Thank you. If you like this video, kindly promote it.